My name is Mr. Ademujimi Adedoto. We'll be looking at Ohm's Law. What is Ohm's Law? Ohm's Law, the man founded a law, okay, or postulated this law in 1826. 1826, Ohm postulated a law called what? Ohm's Law, which states that the current flowing or passing through a metallic conductor is directly proportional to the applied voltage or potential difference, provided that the temperature and some other physical properties of the material remain constant. Okay? Mathematically, we have V directly proportional to the applied what? Current, applied what? Voltage. Okay? This is what we call sign of proportionality. Sign of proportionality. And to remove this sign, you need to apply equals to, then followed by K. Are we together? So we can say V is equals to Ki, isn't it? So V, where K equals to what? R. Okay? K equals to R. So therefore we can have V to be equals to what? I what? I. So this is the mathematical what? Representation of Ohm's Law. Are we together? Okay? So let's quickly look at this. The relationship between the three variables. Okay? We have this to be V. This is I. While this is what? R. Okay? If you want to get V, close V, it means that current times R, that will give you V. Current times R is resistor, I is current. Current times this will give you what? Voltage. Then for you to get this, if you want to get current, it means that current closes. We'll be left with what? What can you see there? V over what? Over R, isn't it? So that's the formula for finding current. Okay? So if you want to get R closes, we can have R to be equals to V over what? Over I. So this is the definition of what? Of resistance. This is the definition of what? Of resistance by what? By Ohm's Law, or from Ohm's Law. This is the definition. Okay, and what can we deduce from it? We can deduce that resistance is what? Is the ratio of what? Of PD. That's the potential difference to what? To the current. Are we together? That is the definition. Okay, so from there we move to arrangement. Arrangement of what? Of resistors. Arrangement of resistors. Resistors can be arranged in two ways. One, we have a series arrangement. Two, we have what? Parallel arrangement and series arrangement. If you are talking about what the series arrangement, in the series arrangement, when two or more resistors of resistance R1, R2, and R3 are arranged in series, they will have what? The same current. The same current, that the same current will flow, but different what? PD. That is, there will be different what? Voltage drop. Now look at it. Three resistors connected in series. This is series arrangement. Okay? This is all for series arrangement. Okay? Once they are connected in series, same current will what? Will flow. That is, I1 will be the same as I2, the same as what? As I3. Same as I3. So from there now, what can we deduce from there? We can deduce that, okay, a circuit where there is what? Voltage and load. Voltage and what? And load. These are called what? Loads. Okay? Since they are in this circuit, what will happen? There will be what? Current will flow. Current will flow. That will be I total. I total will be the same as what? I1, I2, and I3, isn't it? That means I total equals to I1 equals to I2 equals to I2 equals to what? I3. Okay? They will have the same what? The same current. Same current will flow, same current. But what will happen to the potential difference? Potential difference will be what? Different. They are not the same. They are not the same. That will be V1. This will be V2. This will be what? V3. Okay? Such that the total voltage must be equal to sum of the three voltages. So that will be V total equals to V1 plus V2 plus V3. Okay? So that the sum of this must be equal to this. Must be equal. Must not be more than this or less than this. Not possible. Not possible. Okay? So what's V total? What's V total? We know that, recall, from Ohm's Law. Recall, from Ohm's Law, that V equals to IR. That V equals to IR. So compare and contrast, meaning that V1 will give us I1, R1, isn't it? So comma V2, I2, R2, and V3 will give us what? I3, R3. Okay? Then substitute in the value for V. Put in the value of V. So we have V total. What's V total? V total will be I total, R total. Equals to, what's V1? V1 is I1, R1 plus, what's V2? V2 is I2, R2 plus, what's V3? V3 is I3, R3, okay? But we said something that I total is still the same thing as I1, I2, and I3. It means that the currents are the same, okay? So we have I total, R total equals to IT, RT, sorry, R1 plus IT, R2 plus IT, R3. Okay? IT is common into bracket R1, R2, R3 equals to IT, R1, after and both. Okay? After we keep both. So we left with what here? RT equals to what? What do I have? R1 plus what? R2, R2, R3. Okay? This is the formula when two or more resistors are what? Arranged in series. Arranged in series. So therefore we can have R total to be equals to R1 plus R2 plus R3 blah 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 R what? N. R what? Rn. Okay? So let's look at what? The parallel combination. Parallel combination. Okay? This is what we call parallel combination. When three resistors of resistance R1, R2, and R3 are connected in parallel. In parallel, they will have what? The same voltage. Same voltage, but different what? Different current. That is, once there's what? This, we call these loads. Okay? So, circuit that contain what? Loads and what? Source. That's the voltage. So what will happen? There must be current. Current will flow. That's the rule. Okay? And once this current gets to where? To this junction. What happens? The current will what? Will split. So we'll be having I1, I2, and what? I3. Okay? Such that I total must be equals to what? Must be equals to I1 plus I2 plus what? I3. Okay? Such that that the sum of the current must be equal to this, not less than this, but exactly this. Are we together? Okay? And V total will be equals to V1, equals to V2, equals to V3. Because this is parallel connection, you'll be having the same work, the same voltage. Same voltage. Okay? So recall from what? From Ohm's law that V, recall that V equals to IR, isn't it? So I will be equals to V over what? Over R. Okay? So we can have I1 will be equals to what? That's V1 over R1. I2 will be equals to V2 over R2. And what? I3 equals to what? V3 over what? R3. Alright? So we can say I total, what will be I total? I total will be equals to what? V over what? Over R total equals to I1 is what? V1, that will be V over R1, because they are connected in what? In parallel, so they will have the same voltage. Okay? Plus I2. I2 is V2 upon R2 plus I3 is what? V3 upon R3. Okay? That's V. That's V. Okay? So from here, so we have V upon what? R total equals to V 1 over R1 plus 1 over R2 plus 1 over what? R3. Okay? This, 1, right? So that will be what? 1 over R total. 1 over R total will be equals to 1 over R1 plus 1 over R2 plus 1 over what? R3. That is, when you have this in parallel, the total resistance or the equivalent resistance or the resultant resistance or the effective resistance will be equals to the reciprocal of each resistor. Reciprocal, that is 1 over, or inverse. That's it. So from there we can say therefore 1 over RT equals to 1 over R1, 1 over R2 plus 1 over R3, blah blah blah, 1 over R what? N. That's the formula. That is, when we have more than 3 resistors connected in parallel, okay, we have more than 3, okay, to be like that, till you get to what? To the last resistor. Now, note, when 2 resistors are connected in parallel, they are effective or equivalent or resultant resistance, that will be R total or R effective, must be equals to R1 times R2 over R1 plus R2. When you have what? 2 resistors, okay? That will give us what? R total equals to R1 times R2 over what? R1 plus R2. Still the same as 1 over, you just use it since you are giving 2 resistors connected in parallel. Take note. Take note. Now, two resistors of resistance 2 ohm each are connected to a 12-volt battery. Find A. Series combination. B. Parallel combination. Solution. That's solution. A. You have to draw the circuit diagram. Draw the circuit diagram. Since you are told that what? In series first. In series. Connected to what? To a 12-volt battery. To a 12-volt battery. Okay? That is 12 volts battery. So 2 ohms what? Each. 2 ohms each. So what will be the R total in series? In series. So R total. So R1 is equal to what? 2 ohms. And R2 equals what? 2 ohms. Isn't it? So we want to find R total. Now given. Recall that what? That R total equals to R1 times R2 over what? R1 plus R2. That's equals to R1 plus R2 plus R3 plus blah 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 Rn. So what's R1? R1 is what? 2 ohms plus R2 is what? 2 ohms equals to 4 ohms. That will be R total when connected in what? In series. When connected in what? In series. So let's look at the parallel arrangement. B. Parallel combination. Parallel combination. Parallel combination. Okay. So what will be the total resistance? Recall that what? That 1 over R total equals to 1 over R1 plus 1 over R2, 1 over R3 plus blah blah 1 over Rn. Okay. So that will be 1 over R total. 1 over R total. 1 over R1 is what? 2. R2 is what? 2. That will be what will be the LCM? 2. How many 2 can we see in 2? 1 times 1. 1. 2 into 1 times 1. So that will be what? 2 over 2. So 1 over R total equals to this. So we can have R total to be equal to 2 over 2. That is 1 what? 1 ohm. So this is their effective resistance when they are connected in what? In parallel. In parallel. In parallel. If R1, if R2 and R3 are connected in parallel, find the effective resistance of resistors R1, R2 and R3. If R2 and R3 are connected in parallel, in series, connected in parallel with R1 in what? In series. Find the what? Effective resistance. That's total resistance. Okay? So draw the circuit diagram. We are told that solution. We are told that R2 is what? Parallel to what? To R3. R2 and R3 are what? In parallel connection. Then this parallel connection are now in what? In series to what? To resistor R1. Okay? Let's draw the diagram. R1. Okay? If in series R1 equals to 1 ohms, R2 equals to 3 ohms, and R4 equals to 6 ohms. Okay? Equals to 6 ohms. So we can have what here? We can have this in parallel. This R1, which is equals to 1 ohm. In parallel. Okay? This is in parallel to this. Zoom. Zoom, 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 zoom. Zoom, 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 zoom. V minus. This is R2. R2 is what? 3 ohms. And this is R3. R3 is what? 6 ohms. Okay? We have to find what? The effective resistance. That's the total resistance. That's the total resistance. Okay? Now, in series, in parallel, we have R1 to be what? 1 ohms. 1 ohm. So R2 equals 3 ohms. R3 equals 6 ohms. Okay? But R2 is parallel to R3. This is sign for parallel. They are parallel. Okay? So we can have R total, not the effective now. R total for parallel. We can do like this. Parallel. The total resistance in parallel will be equals to R1 times R2 over what? R1 plus R2. Don't forget that I said, when two resistors are connected in parallel, when they are connected in parallel, the effective resultant or total or the equivalent resistance will be R1 times R2 over R1 plus R2, which is equal to what's R1. So we are using R what? R2 now. So it means that this will be R2, this will be R3, okay? This will be R2, while this will be R3, okay? What's R2? R2 is 3. 3 times 6 over 3 plus 6. 3 times 6, that's what? 18. Upon this will give us what? That's 9, alright? So everything will give us what? That's 2 ohms. Meaning that we are in parallel. Okay, the parallel connection now is this. The total resistance in parallel is this, so you can redraw the circuit diagram, and that gives what? This, okay? This has already been resolved to what? To 2 ohms, while this is 1 ohm. Okay? So V. So therefore we can have R total or R effective. R effective equals to 1 plus 2. And what would that be? That would be 3 ohms. That would be R effective. R effective. R1 is 2, 3, parallel force, 3 times 6, that's 18, 9. Okay, divide, that will give us 2. 9 times 2 is 18. Okay. Example 3. To a battery source of 12 volts. To a battery source of 15 volts. Find the current. Find, let's have it this way. Find A. Total current in the circuit. Find the total current flowing in the circuit. B. The current that flows in each resistor. If two resistors of resistance 5 ohms and 10 ohms are connected in parallel to a battery source of 15 volts, find the A. Total current flowing in the circuit. B. Current that flows in each resistor. Solution. First thing to do is to draw the circuit diagram. So let's have the circuit diagram. We're told that they are connected in what? In parallel. So this is parallel arrangement. This is parallel arrangement. So a battery source of what? Of 15 volts. A battery source of 15 volts. Okay? What's R1? R1 is 5 ohms. What's R2? R2 is 10 ohms. Okay? Once there's what? Load and source, what will happen? Current will flow. That's the rule. There must be current. But current is unknown. But since these are connected in parallel, what will happen? There will be what? Different what? Current. Due to what? Due to this junction. When the current gets to this junction, what will happen? It will split. Okay? Due to that, but they will have the same what? Potential difference. Are we together? So we can say R1 equals to what? 5 ohms. R2 equals what? 10 ohms. R total is unknown. R total is unknown. I total is unknown. And we have V 15 volts. Okay? Then we know that what? We know that R total is equal to R1 times R2 over R1 plus R2. You can still use 1 over R1 plus 1 over R2 equals to 1 over R total. So you get the same thing. But this is just more faster than this, okay? Equals to what's R1? That's 5 times what? Times 10 over what? 5 plus 10, isn't it? And what would that be? That would be 50 upon what? Upon 15. Yes. You can divide it by 5. Divided by 5. Divided by what? By 5. You reduce it. And that will give you what? That will give 10 upon what? Upon 3. Upon 3. Okay? That's the total what? Total resistance. Okay? So what will be the total current? The total current will be what? We know that. Recall from your Ohms law that V equals to IR, isn't it? So this will be as our I total. So I total will be equals to what? Will be equals to V over what? Over R total. Then what's V? V is 15. That will be 15 upon what? R total. R total is what? 10 upon 3. Okay? And that will give us what? That will give us 15 times 3. Everything upon what? Upon 10. Are we together? So this will give us 45. 45 divided by 10. And what this way? That That will give us 4.5 ampere. That's 4.5 amps. So 4.5 amps is the total current flowing through this what? Circuit. Okay? Then, that's for this. Then we have to do this again. Let's tidy up that. So this is I1. This is what? I2. Because they are connected in what? In parallel. Such that I total must be equal to I1 plus I2. Take note of that, okay? So, since we have gotten our I total, what will be I1? I1 will be, since they are connected in what? In parallel, they will have the same voltage, but different what? Different current, okay? So, I1 will be, since they will be having the same voltage, that will be 15 divided by what? By 5, and I will give 3 ampere. That's 3 amps, okay? That's for I1. What will be I2? I2 will be what? I2 will be total, which is 15 divided by what? Divided by 10. And what would that be? 1.5 amp. Okay? To justify the answer now, so we can just say what? Let's check if you are right or wrong. Check. We know that I total must be equal to I1 plus what? I2. So what's I total? Our total current is 4.5, which must be equal to sum of this. So if you have this and this together, 3 plus 1.5, we give 4.5. That's 3 plus 1.5 equals to 4.5. Therefore, we can say the one on the left hand side is equal to the right and what side? Thank you and God bless you.